Alright, this video is for Lesson 1 of Unit 7, which is about logarithms and solving exponential functions with logarithms. In the first lesson, we're just going to introduce to you what a logarithm is by graphing two different kinds of functions. Alright, so at the very top it says when we originally found inverses of functions way back in Unit, I want to say 2 or 3 here, we always switch the x and the y values. So we would have a linear function and we would say find the inverse. You would flip-flop the letters x and y and then solve for y. We're going to do something similar here when we are finding the inverses of exponential functions, which is what we have in part A. F of x equals 2 to the x. Over here on the left, we're going to fill in this table for the graph 2 to the x and then graph it on the grid. So pull up your calculator or Desmos here, and we'll type in the function y equals 2 to the x. You're going to need the table, so go ahead and make a table. And it looks like the points we're graphing are from -2 to 4. So I have -2 to 2 here. So what I'm going to do is I'm going to type in the table here. You should do this on your own screen. I'm going to hit pause and I'm going to plot those points. You should do the same thing for yourself. Alright, so I've plotted my points. I'm just going to connect those points with a nice smooth curve. And that should look like the exponential functions that we graphed in the last unit. Now I'm going to flip down, I'm going to skip to the box on the bottom right underneath the grid and look at the first line here. It says for f of x, for the function we just graphed, there's an asymptote where. Well, the thing you need to remember, and hopefully you know this, or you've heard this word before, an asymptote is a line that your graph approaches but never reaches. Now, if we're looking at our graph here, you should see that down here towards the x-axis, this graph looks like it's getting really close. It's hard to tell from the smartboard, but you're 1/2, 1/4, the next point will be at 1/8, 1/16, 1/32. You get really close to that axis there, but you never actually touch it. That means there's something called an asymptote there. So there's an asymptote at the x-axis. The equation for that is y equals 0. I want you to write both of those. Alright, now let's skip to B. So fill in the table below for the inverse of f of x. Remember, the inverse flip-flops the x and the y values from the original table. So all you have to do over there, in the column that says f of x, that's going to be under the x's now. So you'll start with 0.25, 0.5, all the way up to 16. That's your new x's. Your f inverse of x, or your y's, is the same as the original x column. Now that you have those points, you've switched the x and y to find the inverse, you're going to plot them. So you have 0.25, -2, just estimate. 0.5, -1, 1, 0. 2, 1, 4, 2, 8, 3, and I'm going to estimate 16, 4. Alright, so again, you should see when you graph these with a curve, it does look kind of like a mirror image of the original graph, and it also looks like this graph has an asymptote, but this time the asymptote looks like it's coming along the y-axis here. It's getting really close, but it's not quite going to touch. So in the box underneath, f inverse of x appears to have an asymptote at the y-axis, which the equation for that is x equals 0. So notice that the asymptotes are at the opposite axes. Now, you should hopefully remember that all inverses are going to reflect over the line y equals x. Now, if you don't know what y equals x looks like, graph it on Desmos to double check. All right, y equals x is a slanted line that goes through the origin with slope of 1. All right, so if we graph that on our grid here, we start at the origin, we go up 1 over 1, all the way to the end of our graph. You need to pause the video so that you can plot these points. I'm just going to graph it here so you can see. So this is y equals x. And I forgot to label our original graph, so I'm going to do that now. We had f of x and f inverse of x. So you should see that the purple and the pink graphs look like they reflect their mirror images over the line y equals x. All right, let's look at one more. We're going to do the same process, different original function. So this time we're starting with y equals 3 to the x. So we'll do the same thing. We'll go back to Desmos. I'm just going to change the function here to be 3 to the x. And we're just going up our table to 2. So I'm going to delete out some of these points. So again, I'm going to hit pause. You can copy the table over, and then we'll plot our points. All right, so as you're connecting these dots, or as I'm connecting them, on the table, Desmos gave you the decimal approximations, but for -2, if you wanted the fraction, that's equal to 1/9, and then for -1, 0.3 repeating is 1/3. All right, so I've graphed our points here. Now, same thing as the last time, in the box underneath, there appears to be an asymptote for this graph, again, at the x-axis, or y equals 0. I'm going to find the inverse now. Again, the inverse we get by flip-flopping the x and the y values. We switch them and then fill in our table. So our x's here will be 1/9, 1/3, 139. And then my y values are the y values from my table, or the x values from my original table. And now I can plot some at 1/9, -2, 3, 1, and 9, 2. And I'll connect those. Similar shape as the graph before. This graph, as does example 1, appears to have an asymptote at the y-axis, or x equals 0. And same as the last time, these graphs tend to look like they are reflecting over the line y equals x. So you can go ahead and sketch that line. I'm just going to estimate it here, right through. So it's a good thing that these graphs look like mirror images. Now we're going to put a name to this inverse, to this new graph that we created. So go ahead and flip your paper over once you're ready, and we'll figure out what this is. Since these inverses that you were just graphing have a special name, we call these inverses logarithms. So logarithms. Now, when we did inverses originally, we did inverses of lines. And the inverse of a line is a line, so that's pretty easy. Here, the inverse of an exponential function. So the inverse of these graphs that were a times b to the x is called a logarithm. And we're going to look at the equations of those in just a minute. But it's not another exponential. It's a whole different function. Now, on the first two graphs, when I look here, it says where are the y-intercepts of the logarithm? So I'm looking at the pink graph on both of these. Well, remember, these pink graphs had asymptotes at the y-axis. It never touched. So that means it has no y-intercept. For the pink graphs again, though, when I look at the x-intercept right here, it looked like it did have an x-intercept at 1, 0 for both of those graphs. So we have x-intercepts at 1, 0. It looks like the trend of the graph, both pink graphs are increasing. Now the domain. Remember, domain is left to right. I'm going to undo. Oops. Alright, so my left side, I started at the y-axis, which is 0, but I never actually get there. And then my graph has an arrow on the end that goes to infinity. So since I have an asymptote at x equals 0, when I write my domain, I'm not going to include that 0 in the domain. It doesn't have a value at x equals 0. So open parenthesis, comma, infinity because they go to the right. Now my range is going from the bottom where I have an arrow, so down to infinity, up to positive infinity. So my range is from negative infinity to infinity. All right, let's talk a little bit about the equation of a logarithm. It's going to look a little funky right now. Don't worry too much about this. This is just getting you to see what kind of the equation of a logarithm will look like, and the next lesson will really solidify and make sure that you understand the definition. So it says for an exponential function, its inverse is the logarithm. It's written this way: log base b, so the letter b is the base, of y equals x. Now, how did I get that? Here's what I did. I made a little curly Q. We're going to make a lot of curly Q's here. I start at the base of the exponential. I curl over towards what we're equal to and end with the exponent. So I wrote the b first, that's where I start. Then the y I wrote, and the last letter I wrote was the exponent. Let's do a couple of these to start. We graphed f of x equals 2 to the x. That's the same as y equals 2 to the x. That was the first graph that we made at the very beginning of our notes. The inverse of this function, let's make our curly Q. We start with the base, which is 2. So we'll have log base 2, curl over to the y, so of y equals, I end at the exponent. That's the equation of the inverse. So if I go back here, this inverse, this function that I graphed, was log base 2 of y equals x. That's the same equation of that pink graph. I can do the same thing for this next graph. I'm going to rewrite it with the y. Now the inverse of this function, I start with log, then I write the base of the exponential, log base 3, go over to what we're equal to of y equals the exponent of x. And that is the equation in example 2. Log base 3 of y equals x. So fill those in on your notes. And then there's a couple practice problems here on the end, just to practice writing the inverse functions, and then we'll do more with logarithms in the next lesson.